Right, morning. Welcome to another session of computer architecture. And naturally, as discussed before, what we're doing today is distinctively looking at essential peripherals, which is going to be chapter 10 in your prescribed textbook, the 10th edition, or chapter number 11 in the 9th. So it's important for you to just take cognizance of that distinctive fact there. So what we will do as far as today's session would go is just understanding what's happening with obviously supporting multi-purpose connectors, also looking at the whole concept of identifying and installing standard peripherals on a machine, and then a look at installation and understanding what's happening with the standard storage devices within your setup that are obviously not SSD or HDD. And their distinctive media, because if you remember well, I think during the course of the week, I had initially asked of you to have a quick look at the uploaded clips, I think all the way from firmware to implementing mass storage. So that at least we can maximize the time we've got as far as module content is concerned. So what we'll do today, again, like I said a couple of moments ago, focus on essential peripherals, and then on Thursday session we'll discuss what's happening with the command line. So what we are also proposing or trying to get done for us is that, remember, your assignment has got a practical part per se. Question number 3 of that assignment is literally going to ask you to disassemble a computing system, or literally your system unit, and then we'll need to take images of the internals in terms of which components are relevant with regards to the actual question. I think they've asked you to look at 5 distinctive components. So examples would include your motherboards, your PSUs, your hard drives, RAM and CPUs. These are all examples of the components that we'll need to use. And then just give a summary of what these components are responsible for when it comes to the computer system, and then what are the common issues, and then what are the distinctive resolutions that are common when it comes to those problems there. I've already discussed the assignment, so there is the clip that is there on the channel as well that discusses the core 5111 or core F120 assignment. I think it's one and the same thing. Have a quick look at that if you haven't already, so that at least on the 15th of May, which is our next face-to-face session, we can use that to run the practical, and also probably incorporate a bit of test revision, because remember, you've got your tests coming up. So if I've got the dates correct when it comes to your assessments, we distinctively mentioned the 8th of June for the assignment, and if I'm not mistaken, the 21st of May as the date for your test. So if there've been any changes, please give me a shout on that one. But if I'm not mistaken, I think from your pairs, those are the dates that are literally imperative for us to just take heed of. So we'll need to obviously do test revision a week or so before. There are clips again discussing the 2015, 2016, and then the 2017 test paper. But I think what we will do in terms of our revision is probably focus on 2018 all the way to 2020. And then you can obviously use that acumen to prepare yourself for the test. Literally, it's all about just understanding what types of questioning is associated with this particular paper. 60 minutes, which is your hour. And if I'm not mistaken, you also have 60 marks associated with this particular test as well. So just familiarizing ourselves in the way in which they ask questions at this particular level, and obviously what you're supposed to be doing in terms of responding to these questions. Right, so I think that's our outlook for the next a week or so. So like I was saying, 6th of May command line, and then the Saturday that follows, which is the 8th, security, and then the 15th we'll look at practical assignments there. As far as your setup would go. So you'll also discover that on the channel. I think yesterday I also posted the printers chapter there, which is chapter number, it should be 26 in your prescribed textbooks, the 10th edition, and then obviously 27 in the 9th. You can also have a quick look at that, because what that does for you as well is that that particular session would assist with the question number 4 of your assignment. Remember, you're also going to be discussing printers in that distinctive assignment. So the 4th question is looking at you just comparing inkjet and laser printing. I think I discussed that in that particular clip as well. So you have a quick look at it. Should there be any issues in terms of you not understanding some of the content, naturally just pop me a mail, and then we can always engage ourselves accordingly as far as that or that content would go. So what that would mean is we are sorted when it comes to the assignment, really, in terms of acumen that you need. The only remaining thing is just the practical part, like I said before, which we'll do in the next week or two, and then we'll get that one done and dusted. So anyway, when we've been talking about computing systems at large over the past couple of weeks or so, I think most of our concentration was obviously on the components that literally enable proper functionality of these computing systems. We discussed RAM, CPU. Obviously, when you look at the clips, I asked you to have a look at motherboards, and hard drives are also incorporated there. So these are different components that obviously work within your system unit, which is normally the computer box that we've been talking about also for a couple of weeks. Now, it's imperative for you to understand what else works with the computer system to complement what it provides for, as far as our particular machining mechanisms would go. So the main focus of today's chapter really is not, excuse me, looking at the whole concept of ports or devices that are literally used by standalone monitors, for instance, but or a typical computer display, but literally just looking at components that literally complement the computing system. So obviously, what we plug into your system unit, and what literally extends or enhances the capabilities of your computing system. So understanding what's happening with the ports, because if we go back to maybe, let me see if I can share my screen here. Let's see if we can create the notes as we go along as well. Right. So if you look at what we've discussed in previous sessions, I think we did mention the whole issue of the computing process, right? And as far as that is concerned, obviously, if you look at your basic computing process, remember we initially mentioned that it was just initially incorporated. It just initially had 3 distinctive stages: your input, process, output. But obviously, with the advancement of technology, there, storage and networking was typically incorporated. So you will discuss input naturally. You will also look at your process. We'll also discuss your output, and also mention storage. And then, not forgetting, I think we'll put our 5th here as networking. All right, so just put it as network there. All right, so if you look at what we've literally discussed before, we mentioned the fact that each one of these stages will obviously have distinctive hardware components that are responsible for providing that function. And obviously, as far as your particular input is concerned, we did discuss a typical example of your mouse, and naturally things like your keyboards, for argument's sake. So our focus is going to be looking at the ports that enable connectivity of these particular devices, just for argument's sake. So these are literally associated. This is what you would call a peripheral device, something you plug into your system unit, or something you plug into a distinctive connection point or your port that literally enables you to, like we were mentioning a couple of moments back, complement the computing system at large. And what you're looking at as far as your output also would go, again, same difference applies. We can discuss your monitors. You can also talk about your speakers. So we want to look at speakers here. What's happening now? All right, as typical examples, or even printers as well. You can also even discuss your printing as typical examples of some of the components that you got there. So what we're going to be focusing on is literally, as far as your session there is concerned, is obviously what enables connectivity to your mouse, your keyboard, your speakers, and your printers, for instance. And then obviously when you're looking at storage, the focus is more on storage components that are not obviously SSD or HDD, that obviously has been covered in the previous sessions, and it doesn't really relate to those components acting or behaving or functioning as peripheral devices. The same difference would go with your monitors. There's a dedicated chapter which is display technologies, which will obviously take into consideration these particular gadgets in detail. So obviously our focus, like I said before, is the ports that obviously enable the basics in terms of your mouse, your keyboard, your speakers, and printers as typical examples. You can also even mention and throw into the foray there such content as your joysticks, for instance, just for argument's sake. But naturally, that's what our peripheral devices are literally distinctively focusing on. So the main thing that you want to also discuss there or throw into that particular is the whole concept of ports, right? So you remember your port is a connection point associated with your distinctive components. You've got your generic serial ports that were obviously responsible for distinctive connectivity associated with your environment. And when you're looking at these ports, serial was your default go-to as far as the connection would go. Remember, you've got the difference between serial and parallel. And like we've mentioned before, in the whole concept of understanding the differences in architecture and speed per se, is that normally with a parallel connection, the reason why it's slightly slower as compared to its serial counterpart is the fact that your parallel shares communicate. It's a shared communication channel. So anything that is shared obviously is bound to be a bit slower because you've got something that is literally not dedicated, if you want to look at it from a different point of view. But on the other hand, the serial communication is looking at point-to-point dedicated communication that is obviously not shared. That's the reason why communication within that environment is a bit faster as compared to your parallel communications there. So initially, most older devices would connect to these serial ports, and the specific serial port that was used back in that environment was the RS-232 connection. So RS-232 is short for recommended standard. And this was introduced all the way back when these machines were initially crafted and distinctively deployed. So back in the 60s, this was the initial port that was used to provide for connectivity to your to basic peripheral components associated with connectivity there. But obviously, there was a need to look at upgrading because, like we've mentioned before, some of the issues associated with dedicated ports. So if you go back to this particular slide here, if you looked at your mouse, your keyboard, your speakers and printers, just for argument's sake, your computer system was designed to have dedicated ports for each of these devices, right? But the distinctive problem there is that configuration can become a bit cumbersome, and it doesn't really avail for technological advancement in that arena. So to avail for a better configuration as far as your machines would go, there was a need to create at least a port or ports that can accommodate from a multitude of devices without the need of having a dedicated port for these devices there. So remember, if you look at the whole concept of what we've got here, initially dedicated port for a mouse, dedicated port for a keyboard, dedicated port for your speakers naturally, and then dedicated port for your printers. But this particular port that provides for a better configuration per se would be your USB port, which you're literally familiar with. And remember, USB is short for Universal Serial Bus. Right. Remember, we mentioned that a bus is any communications channel when you're looking at it from an ICT point of view. And what this USB port at least does from an advancement point of view is, and then enable connectivity of those devices that we were talking about earlier on. Now, instead of having dedicated ports for the mouse, your keyboard, your printer, and obviously speakers, you can use that one port for connectivity as far as configurations would go. And the other advantage is that you can also use a USB port to literally charge or power up your devices, whichever way you want to look at it. So it's that particular port literally serves a dual purpose, that you can deal with data and charge as well. So with this particular port, you literally can deal with sending data or signals, whichever way you want to look at it, and at the same time, you can also look at charging. Right, which obviously makes it a bit of a plus there when it comes to basic configurations associated with your setup. But now, how this particular port literally functions, for you to understand the whole concept of what is happening here. We've mentioned instances, I think, in the mass storage clip and chapter there, that excuse me, when you look at connectivity of these devices, right, especially when you connect it to your motherboard, because your motherboard creates literally the backbone of any machine, or the most is it lays a foundation for every computing system, because everything literally connects or becomes part and parcel of the machine through that particular printed circuit board or motherboard. You've got an interface that is obviously within your physical environment. You also have a controller, and that particular setup is then responsible for availing for connectivity associated with your devices. So, if you want to look at it from a different point of view, let's see if we can quickly switch this up. Right. So initially, if you look at what we've got on screen there, this is a typical example of what your basic RS-232 connection was like for connecting your peripheral components. So your recommended standard 232 would look like that, and this is also known as a DB 9 connection. So the DB is short for D sub miniature, and the 9 is just representing the number of connection points, if you want to look at it from a different point of view associated with that setup. So if you can look at the female and the male connector there, you've got 9 pins, and then you also have 9 holes in which those pins would typically plug into. So you also had these particular configurations, the DB25 associated with your printer ports. But like I mentioned before, now USB has literally become your basic port as far as connectivity would go. So if you want to look at it in this particular instance now, when you've got your USB configurations, right? So your USB deals with what is known as a hubbed architecture, right? Where, remember, when you're discussing hubs, you've got a central connection point of either devices or components within a distinctive architecture environment. And in this particular instance here, you've got a host controller that is responsible for ensuring connectivity between those particular, or that particular architecture in terms of the actual USB configuration itself, and naturally the chipset, which will then also connect to your CPU. And then with that particular controller is connected directly to the root hub. That root hub is the one that enables a multitude of ports to be accessible as well as usable, and literally connect to that USB controller for connectivity's sake. So then after that, your multitude of ports would then distinctively connect there. So you've got a host controller, root hub, and your USB ports in a typical environment. And these particular controllers would support up to 127 devices. So that is also a bit of a plus there when you look at connectivity. Your host controller is designed to literally support 127 devices. But literally, if you want to look at it from a different point of view, what that then would say is obviously in real life environments or in the actual physical sense, you've got the distinctive limits that are there. But naturally on paper, you're looking at 127 devices associated with connectivity there. So if you want to look at it from a different point of view now, your USB or your core USB environment there, the controller is integrated circuitry. So like we were mentioning earlier on, this particular controller is then found on your motherboard. That's the one that actually provides for your devices to literally function and provides for a connectivity from that particular device to your chipset as far as your environments would go. Remember, we've discussed this, I think, probably superficially in one of our sessions. But if you did have a quick look at the clips there, you'd understand what's happening with the whole concept of the chipset. So let me see if I can quickly go back again for you to understand what is going on here. Right. So if you want to look at the whole concept of the chipset, like we were mentioning earlier on, its main purpose is just to determine compatible CPU and RAM conventions. I think if you look at a bit of history, when it comes to your configurations there, you've got your initial central processing unit. Then you've got what is known as the North Bridge. Then you also have what is incorporated as the South Bridge. So you've got a CPU here. Then you've got your North Bridge. Then you've got your South Bridge. Okay, let's write this down appropriately. So then you've got your South Bridge as a typical part and parcel of your chipset. So you've got connections in that particular instance. So South Bridge connects to the North Bridge, and then North Bridge directly to your central processing unit. And if you want to look at it from a different point of view, your North Bridge's main purpose back in the day was to obviously connect important components, which would be your RAM and distinctively your graphics there. And then your South Bridge would deal with input-output devices or ports. All right, so let's just put this as devices, input-output devices, as far as your particular machining mechanisms would go. So obviously, what we're looking at is all the ports that enable connectivity of the peripheral devices would be availed for by the South Bridge. But now you'll discover that your later day CPUs and architectures now incorporate North Bridge architecture directly into your central processing unit. And then you now have the South Bridge as the lone entity associated with the chipset. Intel normally associates that as the platform controller hub, and then AMD would discuss that as just generically the chipset. So if you want to look at an upgraded setup associated with your chipset, what you now have is just your central processing unit that obviously now connects to your South Bridge, and then CPU there. And then naturally, as far as the South Bridge is concerned, again, like we mentioned before, still responsible for your input-output devices there, all right? So input-output devices are still applicable in that distinctive environment. So the CPU now has integrated memory controller chips, has integrated graphics. That's part and parcel of what the CPU now provides for. So your North Bridge is no longer existing as far as the actual chipset would go. So what the root hub or what the controller we were talking about earlier on is responsible for now is to avail for direct connectivity to your South Bridge. It's the host controller we were talking about earlier on provides for direct connectivity to your South Bridge. That particular South Bridge now enables whatever devices that you connect. So, for instance, we are now saying our controller is now part and parcel. Or is literally associated. So our controller there, maybe let's put that. Let's try to do this. Let's put that in a different color, possibly. So if you want to look at it from a different point of view, we are now saying that your host controller. So here is our host controller that's linked directly to your. That is linked directly to your South Bridge environments there that will then avail for connectivity of the devices we're talking about. For instance, devices such as your keyboard. So your keyboards there. And possibly your mouse as typical examples of some of the devices or gadgets that are incorporated as far as your machining mechanisms would go. So the host control, that's what the host controller does for you. But naturally, that host controller also enables linkage to your root hub that then will enable connectivity to a multitude of devices that are incorporated there. So if you want to look at it from a different point of view, like I was just mentioning, your USB deals with what they call a hubbed architecture. And obviously with the hub, what we mean is you've got a central connection point, and then you obviously have a multitude of devices that link directly there. So obviously this is what your hub configuration would distinctively look like. And like we mentioned before, its particular purpose would obviously enable connectivity of about 127 rather devices. Now this is different to another architecture which will discuss in a bit, which is your Firewire. On the other hand, Firewire now deals with what they call a daisy chain or daisy chained configuration. And what that typically looks like now is you've got your PC there that connects to a printer, for instance, just for argument's sake. That printer also then connects to an optical drive that then also possibly connects to a hard drive, external hard drive. So here we'll mention external hard drive. Right, apologies, there's my stylus seems to not have woken up this morning. But anyway, so that's the different setup. So that's what you literally call a daisy chained environment where you're connecting devices in serial. On the other hand, your hub configuration, you've got a central platform that is availing for connectivity of or everything converge or everything converges onto one distinctive point when you're discussing hub. On the other hand, with daisy chain, then you're looking at the whole concept of serial connection, and the limitation in terms of devices in this particular architecture is 63 devices there. But we'll obviously look at the actual convention in a bit. So that's the whole concept associated with your USB configuration there. So if you want to go back to our images here, what we can do is, okay, let me see if I can. Right. So if you go back to our images there, that's the type of relationship that we've got. Notice that your hub there is the one that is acting as your central connection point for the multitude of USB ports that can literally be incorporated within your environment there. All right. So on the other hand, now, if you look at the way in which your host controller and actual root hub function, you've got up and downstream when you look at an actual device that is connected to a distinctive USB port there. So literally, you'll find that your host controller's main purpose is to send commands and provide obviously power to your USB devices, like we were mentioning earlier on. So your host controller's main purpose, sending commands and providing power to USB devices there. You might literally call the controller the main component that is relevant when it comes to enabling USB-enabled devices to connect to the USB port. So the controller is literally upstream, controlling devices between or controlling devices that are connected downstream to it. So controller is distinctively upstream, as you can see in that particular image there, that is literally controlling devices connected downstream to it. So if you look at it from a different point of view, that host controller is shared by every device that is plugged into it. And you'll find that speed and power distinctively reduced with each new device. So obviously, the more devices that you plug in, the less power and speed that is incorporated in terms of your environment. Because one of the other drawbacks of having a hubbed architecture is that these configurations are shared across the multitude of devices that you plug in. So the more devices you plug in, the more power is shared, the more speed is shared across your devices there. So the other thing now that is also relevant, especially from an assessment point of view, is just to understand the different types of USB conventions that are there, the actual standards and the speeds associated with connectivity. This would also enable you to understand which devices would be appropriate for a specific type of USB standard, which devices are specifically incorporated for higher standards or higher speeds, if you want to look at it from a different point of view. So initially I had USB 1.1 and all the way down to USB 3.1 there. You can look at the massive jumps in terms of speed across the USB standards. The initial USB that was designed was distinctively 1.1, running at about 1.5 megabits per second. And literally these particular ports were associated with basic devices like your keyboards and your mice. Those the basic peripheral components that we were mentioning a couple of moments back. But then on the other hand, you also have USB 1.1 in terms of upgrades, if you want to look at it from a different point of view, that would distinctively enable connectivity to such devices as your headphones and Bluetooth devices. So that would run at about 12 megabits per second. That is also known as full speed USB. So the names are also imperative for you to remember and distinctively link accordingly to a standard maximum speed as well as common usage. So you've got low speed USB, then you've got full speed USB, and then high speed USB, your generic 2.0 devices running at about 480 megabits per second. At this particular time, Firewire was distinctively introduced. The actual term associated with technical representations there was 1394 actually, IEEE 1394. You had A and B configurations. So the 1394A was initially running at about 400 megabits per second. But 2.0 literally combated that particular speed by providing 480, which is naturally slightly faster, edging 400 megabits per second Firewire. But then Firewire created 1394B, which was running at about 800 megabits per second, initially used for just streaming content from digital cameras, for instance. So your high-speed USB typically within the same vein there in terms of webcams, card scanners, and older flash media devices there, not forgetting your wireless adapters. And then super speed USB was then created, which is your generic 3.0, running at about 5 gigabits per second. So you can see that massive jump from 2.0 in terms of speed associated with your USB conventions there. And then naturally, because of that distinctive speed, you're looking at flash media devices that are obviously applicable there. So anything to do with flash media, external storage, the cameras we were discussing earlier on, and current wireless adapters would work within that vein. So it might obviously not be applicable for you to then connect your keyboard and your mouse in a USB 3.0 port, but it's important for you to understand that your USB conventions are literally backward compatible, all right? Which means that if you've got a USB 2.0 device, we can still plug it into a 1.1 port, but it would only run at the slower speed, right? So that's at least I would want to argue that that's an advantage associated with using USB. You're not limited really in terms of compatibility, but I think it's important to understand what type of devices you can plug in to specific standards there or ports to avoid problems in terms of basic functionality. So backward compatibility, if I got a USB 2.0 device, I can plug it into a 1.1 port, and that particular device should still function without much issue. But when it comes to speed, it will always run at the lowest speed. So it's backward compatible, but literally not forward compatible when it comes to the actual speed itself. So I can still plug in a 1.1 device, for instance, in a USB 2.0 port, but it will all again run in its slower speed. So if I've got a 1.1 device and I plug it into a 2.0 port, that device will still run at the slower speed. All right. So it's important for you to remember that distinctive fact when it comes to your standards. And then your super speed USB that is running within 10 gigabits per second, that's 3.1 now. And naturally, again, still flash media, external storage. And a bit of networking is incorporated with that. So it's very important for you to take cognizance of that distinctive fact there. But I think the main thing is to consider that all the devices will literally won't run any faster than they are designed to. They can connect, but the speeds are always going to be limited in terms of the actual devices that are there. All right, so that's the standards that you'll need to familiarize yourself with when it comes to your generic USB. Just understand what low speed is, and obviously also look at the differences, right? And so when it comes to things like assessments, you might literally be asked a question that would ask you to compare a low speed to high speed USB, taking into consideration what standard names are used for these particular names, and then also looking at considering the speed, and then listing the generic devices that function within these particular standards there. So just imperative for you to remember and understand when it comes to comparisons across the board. And it's also important that within your own personal, professional, as well as assessment spaces, really, to be able to identify what a USB 2.0 port looks like when you actually have a physical computer system in front of you. That's also something that's relevant, just to ensure that we are good to go on that part as well. Be able to physically identify and separate and distinguish or differentiate between these particular devices, as well as ports, especially when you look at your physical computing system. So a typical example of what an expansion card with USB ports would distinctively look like. Remember, again, if you look at the whole concept of firmware and your motherboards, literally these expansion cards just extend, again, the number of ports that you get, or whatever architecture that you're looking at associated with your computing system there. I think we've mentioned this before. If you want to obviously look at a dedicated graphics card, a dedicated sound card, addition of ports like the one that you find on screen now, you can always plug it into your expansion slots. When you're looking at your motherboard, that would obviously then enable you to use that distinctive device. Comes with its own BIOS, literally known as option ROM, that then enables this device to become part and parcel of your computer system. All right, so that's just a typical example of what an expansion card that has USB ports incorporated. So normally you'll find that the reason this is done, most individuals would want to obviously take advantage of the speeds we were talking about earlier on, and your board does not have that. See, this is the limitation associated with onboard ports, because they come part and parcel, or they literally come as attached to your motherboard. So it means that, like we were saying before, that should you want to use something that is faster, and naturally your motherboard cannot avail for that, your best bet is naturally to get an expansion card that can accommodate for those speeds, or that can accommodate for that architecture that is obviously not provided for by the board. So this is the reason why expansion cards become relevant, because you can literally, you're not limited to what your board can offer in terms of speed and architecture. You can always plug in something that is relevant to your environment. So if you want to take advantage of, for instance, super speed USB, and your board does not accommodate for that in terms of the onboard ports, you can then literally get an expansion card that enables you to take advantage of that particular architecture. And then on the other hand, if you want to look at your root hub configuration, remember the root hub that we've got is not just literally limited to a specific type of USB architecture, or a specific type of speed, or a specific type of standard. This particular hub can literally have shared ports, which means that it can accommodate for 1.1 ports. It can also accommodate for 2.1 port configurations there. So literally, it's important for you to understand that your root hub doesn't literally act as a sole platform. It can still accommodate for the varying standards and speeds across the board. But remember, what is imperative in this particular example is the fact that your motherboard, or your specific PCB, would obviously have to have the appropriate controllers that avail for obviously the difference in terms of architecture and speed when it comes to your USB ports. So this is just a typical example of shared ports between 1.1 and 2.0. And then if you want to look at it from a different point of view, on the other hand, what you now have on screen is a shared ports across 1.1 all the way to 3.1 there. But again, like I said before, just remember that your root hub, or your hub's main purpose, is just to provide for multiple connections. But what is imperative, or what is important, or the main architecture to consider there, is obviously your host controller, which is the one that determines the speed, as well as the basic standard that is used in that specific setup. All right. So that's what's happening there as far as your controllers are concerned. I think it's also important for you to understand now the different types of connections that exist, especially when you're looking at basic cabling. So you've got ports that are directly onto or that directly incorporated on your actual board itself, or within your system unit, if you want to look at it from a different point of view. And then you also have ports that are associated with the cables, the ones that either plug into the actual peripheral device itself, or avail for connectivity. And these are the different types of USB connections that you've got. So you've got type A and type B, and there's a difference there in terms of which particular devices, or which particular connections are availed for. So type A is your generic, really, when it comes to this. Is normally incorporated in terms of most of your connections that are there, because it's normally hardwired. So USB A connections are literally ignored per se if you want to look at it from a different point of view, because they are basically hardwired when it comes to your devices or specific configurations. Type B is normally associated with your printers. So any particular USB connected printers, the end of the cable that actually plugs into the printer would typically mimic what you've got as type B in that image that you've got on screen. And then if you want to look at devices that normally would plug into your mini B configurations there, typical examples would include your external hard drive casings. So your external hard drive casings back in the day would literally plug into you would literally plug that particular end of the cable to the actual casing itself. And then micro USB, I think most of us are obviously familiar with this. The one that is normally used to plug into your smartphones for charging and data transfer purposes. And then your micro B, which is 3.0, there is the one that is normally plugged in to your external hard drives again. And after time, these particular external hard drives are within the 2.5-inch size category. So the cases that avail for connectivity in terms of 3.0 speeds there would be represented by micro B. And obviously, when you're discussing micro B, if you want to look at the actual, or if you want to determine the actual difference between micro B and micro 3.0, it's imperative for you to understand and mention a 3.0 there to look at a specific distinction between the two there. All right. And then if you're going to be looking at, remember, you also have type C, which we'll look at in a couple of seconds. You also have type C that is there. I think it's more of a, it's really a brilliant upgrade to micro B, because I think a lot of us have had issues in terms of actually plugging in our devices, especially our smartphones or our tablets, using micro B. Either you find that one of the pins there is not as rigid as you'd want it to be, or you distinctively find that you're failing to get the proper charging or data transfer because your cable is not incorporated accordingly. The list will go on and on. But Type C tries to deal with those kind of issues when it comes to connectivity, because it looks at universal access and connections. It doesn't really matter in which particular direction you plug it in because of its actual shape and size and configuration, every which way it goes. So it makes it a lot easier for connections there. So with the ability for you to actually identify these particular ports when you look at an actual physical machine, especially when you're discussing your desktop versions, what you've got on screen there is a typical example of what a USB 3.0 and a 3.1 port would look like. So what you've got on the left is a 3.0 port. Normally that's incorporated in a bluish color there. And then on the right-hand side, you've got the 3.1 port, or rather you're in the middle, because obviously on the right-hand side there, you've got your multimedia connections in terms of your audio and so on. So in the middle, you've got just on top of this, your RJ45 networking connection or port there. And then just underneath that, you've got your USB 3.1 ports, and that's in a bit of a teal color. All right, so the one on the left, bluish, and then the one in the middle, they're teal. So left 3.0, and then your middle would be 3.1. I think it's also important for you to understand the other colors associated with your standard. So 1.1 is normally a white port in terms of color. The 2.0 is black. The 3.0, as you can see on screen, there is blue, and the 3.1 would be teal. So this is how you identify the different standards. And obviously, this would enable you to understand and to know which particular devices would need to then plug into those in order for you to take full advantage of the architecture and the speed that is there. If you've got a 3.1 device, you know that I've got a 3.1 port, plug it in there. You can take advantage of maximum speed transfers there. as far as configuration is concerned. And then the same difference would apply for your 3.0 port configurations. So again, like I was just mentioning a couple of seconds ago, just remember, again, not just from an assessment point of view, but obviously within your own personal and professional spaces, again, how to distinctively identify the different colors that exist there. So white, 1.1, black, 2.0, blue again, 3.0, and then naturally, your 3.1 would be a teal color that is incorporated there. All right, so that's that. When it comes to some of the generic standards, I think we were just discussing the whole concept of a Type C connection. So what you find on screen there is a typical example of USB Type C. This particular convention uses 24 pins, and literally, as you can see, can be inserted in either orientation or direction. All right, so this fully supports 3.1. So as compared to what we were looking at in the previous images there, that with your micro B, literally you needed to plug it in a specific orientation or in a specific way in order for you to actually get a proper connection and to avail for the charging and the transfer. But with a USB Type C, you can insert it in either orientation or in either direction, and it literally fully supports your 3.1. And you can, it even supports other buses or other architecture like your Thunderbolt, because Thunderbolt is also another port connection that you've got there. And I think you will discover that Type C has now become a bit dominant in terms of the micro USB connections there. All right, I think it's becoming most devices now are coming with Type C, which becomes your generic setup that is incorporated as far as your configurations are concerned. And then the other thing I think that you also need to take into consideration in terms of the actual cable lengths. Again, from an assessment point of view, when you're looking at your actual cable length there, your USB has a maximum cable length of about 5 meters, and then your Firewire that I was mentioning a couple of moments ago is looking at about 4.5 meters as far as connections would go. So I think if you go back here, let's see if we can go back to our notes. So when it comes to maximum cable lengths, I think it's imperative for us to remember. So here we can just mention this as maximum cable, listed as maximum cable lengths. So maximum cable length there. So obviously, if you're discussing USB, you're looking at about 5 meters. And then if you're looking at Firewire rather, Firewire, that's about 4.5 meters. So it's imperative for you to also remember that when it comes to your connections, as far as your cabling perspectives would go there. Going back again to our images. Right. Okay, so there we have it. So when you're discussing your basic hubs, that's a typical example of what a USB hub would look like, just obviously enabling connectivity of a multitude of devices dependent on configurations that you've got. But again, like we mentioned before, more devices, less power, less speed in certain instances. So it's imperative for you to remember that fact, but obviously still provides for connectivity of a multitude of devices that are there. All right. But to be honest, if we talked about support to about 127 devices, but naturally you'll find that most of the motherboard manufacturers there or makers literally only stick to between 6 to 8 actual real USB ports that are there. So your hub now, your USB hub is the one that will then obviously enable connectivity to a multitude of devices that you've got within your specific environment. And then typically, remember, we mentioned that your USB connection or architecture can also be used to power up devices. So naturally, what you've got on the screen is the power management tab or power management environment that you can work with within Device Manager to literally determine what's happening in terms of the power configuration with your the USB architecture is concerned there. All right. And then the Firewire we're discussing earlier on. All right, as far as configurations is concerned, remember Firewire initially designed for streaming content from your digital cameras to your machine, like we were mentioning earlier on, and the actual term IEEE 1394. So I think that should be Institute of Electrical and Electronics Engineers, which is a non-profit making organization that is there that literally is responsible for standardizing any type of communication that takes place. So 1394 is the standard that they created. Literally looks a bit like a USB there, but different in terms of configuration. Like I was saying, IEEE 1394A running at about 400 megabits per second, and then literally upgraded to 800 megabits per second, which was the 1394B convention there. So on the image that you find on screen, you got Firewire 800 on top of your Firewire 400 port as far as connections would go. So I think if we can incorporate content here, what we're actually saying here is the one you find on top is Firewire 800. So this here is Firewire 800. And then the one that is just below it, which is this particular one there, that's Firewire 400. All right. So that's what you've got there as far as your Firewire conventions are concerned. Like I said before, it was initially for the whole issue of streaming content from digital devices, especially your cameras, primarily used with Apple-based devices. But now, obviously, it's been replaced by Thunderbolt. Again, developed by both Intel and Apple for high-speed transfers. So literally an alternative to USB and literally Firewire by directly tapping into the PCI Express buses for external components. And if you want to look at representation, so normally you find that your gadget, laptop or desktop would come with specific labeling, because your USB 3.1 and Thunderbolt connections will literally will look the same, but it's imperative for you to actually clearly have these particular labelings incorporated because they're not compatible. So even if they actually use the same connection, Thunderbolt and USB 3.1 aren't compatible. So it's important for the manufacturers to actually mark this accordingly to avoid any problems. But Thunderbolt is actually quite fast because you get up to 10 gigabits per second comparing to USB 3.1. And then you can also even get much faster throughputs, like 20 gigabits per second by upgrading to Thunderbolt 2. And then on the other hand, Thunderbolt 3 offers about 40 gigabits per second, which is really fast when it comes to transfers. So this is also something that you might need to familiarize yourself with again, just to understand exactly what's happening within your setups. So again, if you want to go back, let's see if we can also populate our notes again. Right, so like I was mentioning a couple of seconds ago, your Firewire, normally associated with the term IEEE 1394. And as far as that is concerned, you can either have A or B. So your A, 1394A, remember we mentioned that typically was initially running at about 400 megabits per second. And then your B upgraded to 800 Mbps. So that's your configuration. So 1394A, 1394B, your configurations associated with your Firewire, initially used with or within Apple-based devices. So Thunderbolt was then obviously created. So this just I think it's important for you to so we can just say primarily in Apple devices. And then naturally Intel developed Thunderbolt. So Thunderbolt literally developed by Intel and Apple. And when it comes to the actual speeds, like we were saying earlier on, you've got your Thunderbolt 1, which typically would compare directly to USB 3.1. They're running at about 10 gigabits per second. Then you got Thunderbolt 2, doubling that at 20 gigabits per second, and then Thunderbolt 3 there, doubling that as well, running at about 40 gigabits per second. So that's quite a massive jump in terms of the actual speeds. All right, and then the last thing that you remember, which is imperative really when it comes to what we were initially looking at is dealing with general port issues. So right, so the general port issues I was mentioning is that a typical example, if you want to check your device manager, you could find what you've got highlighted there is devices that are typically, or a controller that has typically been disabled. And in order for you to obviously ensure that you're functioning accordingly, you need to be enabling that to avoid any discrepancies with basic functionality of your device. So just a question of right-clicking from the context menu that appears, you can then enable that particular device there or controller to enable functionality. All right, so I think that is what is really relevant when it comes to our assessment platforms as far as this particular chapter is concerned. But I will also ask you to look at some kind of research as well, just to enable us to get further understanding in terms of what's happening with the actual content. So So I think from a research point of view, what you can then also look at is just so let's just post this up as basic research. You can look at common peripherals. Let's see if we can write this properly. Common peripherals. So obviously your common peripherals would encompass the keyboards we're talking about all the way to sound processors there. Look at those common peripherals, just understanding exactly how they function without issue. And then I think we can also look at KVM switches as part and parcel of what you would need to incorporate. I'm just trying to go through your text here to ensure. So common peripherals across the board, look through that and have basic descriptions in terms of what these would provide for as far as functionality in a computing system would go there. I think the other thing that would also be distinctively relevant is I think your storage formats. I think let's look at that. So storage devices. So as far as your storage devices is concerned, I think the main concentration there would obviously be flash memory. And your optical discs or optical media. So just look at the different types of flash memory that are there and your optical media in terms of the differences and environments of use. But otherwise, I think that should literally cover that in terms of what is necessary. So common peripherals, look through those. I think your main focus literally should be on KVM switches and just understanding exactly what's happening with your mics and so on as typical examples of components. So when you're looking at speaker support, so I think maybe what you can actually do here to be more specific, let's also look at sound components. So here, I think focus on KVM switches. When you're looking at common peripherals, and you also want to deal with sound components. So KVM switches, I think that's your focus. And also look at, let's see if we can add something else here. So I think we can do a sound sound components as well. So I think that's what your main focus literally should be on as far as these would go. But I think we should literally be sorted. Let me see if I can quickly look at unmuting here. Right. Do we have any questions, contributions, or concerns from anyone on from the floor there? Questions, contributions, and/or concerns? Anyone? Feel free to type in chat there or unmute your mic and let's have a quick chat. Should you have any issues? All right, so any questions, any concerns, any contributions from the floor, anyone? Okay, so it seems everyone's groovy. That's that then. So like I was just mentioning earlier on, I think on Thursday, what we'll do is I'm going to post the slides, obviously. I'll post the slides just after the session and also post the notes that we've just created here. And then what I'll do is, I'll obviously also send another link for the Thursday session, which is going to be command line. Before we look at security in our face-to-face session on in the following next week, Saturday. But otherwise, if we're good, then thanks for attending. Keep smiling, stay positive. We'll see you in the next session. Cheers.